All right, let's try that again. All right, just gonna kind of start all over. So we're gonna repeat myself. So for a single replacement, we have an element plus a compound, and that single element is trying to kick a similar compound out. And if it is successful, then we will have a new compound and a different element will be all by itself. Single replacement reactions only take place if the lone element, the element all by itself, is stronger than the element it is trying to kick out. So that's what you use for your activity series. It goes from the least reactive to the most reactive. So lithium is going to be my most reactive metal. Gold is going to be my least reactive metal. And then on the non-metal sides, we really just look at the halogens, with fluorine being my most reactive and iodine being my least reactive. Non-metals only replace non-metals, and metals only replace metals, with the exception, of course, because chemistry always likes a good exception, being hydrogen. If you notice, this lists my metals, but down here I have hydrogen. So it acts as a metal in this reaction. So when you do these reactions, you're going to look at your lone element and look at what it's trying to replace. If the lone element is higher up than what it's trying to replace, it'll be a good reaction and you can finish it out. If it's not, then we end up with what's called an NR, which simply stands for no reaction. That just means if I mix those things together, there wouldn't be a reaction. They would just stay as they are. So the reason it's important that you know non-metals replace non-metals and metals replace metals. So I should never be saying something like, is lithium stronger than fluorine, where I'm comparing them in two different columns. If you're doing that, then you're trying to replace the wrong thing. All right, let's look at a few of those. All right. So on the first set, these are metals trying to replace a metal. Like I said, hydrogen's the exception in here. So on this one, I have lithium. And so in potassium chloride, potassium's a metal. So lithium is trying to kick out potassium. For it to be able to do that, the lithium has to be more reactive than the potassium. And is it? Here's my lithium and here's my potassium. So it is higher up, which means it's more reactive. So we're going to kick out the potassium. It has to be all by itself. And now lithium will join with chloride to form lithium chloride. You're going to be, you'll be forming a lot of ionic compounds. So be sure that you check your charge and make sure it's written correctly. In this case, lithium is a -1 and chloride, I'm sorry, lithium is a +1, chloride's a -1. So that's why they didn't need any subscripts. All right, if we look at our next one, I have tin, which is a metal, and here's zinc chloride. So tin is trying to kick out the zinc. So is that a good reaction? Is tin more reactive than zinc? No, it's not. It's below zinc. So on this one, to finish it, I just have to put NR, no reaction, and I'm through. On Monday, we'll do some other ones where we have an NR, and they're kind of our hardest ones. So it's really nice when you have an NR because then you don't have to do a bunch of extra work. All right. Tin, SN, is trying to kick out the hydrogen, even though hydrogen is a non-metal, and this is it's acting like a metal. So is tin reactive enough to kick out the hydrogen? Is it higher up on the activity series? Yes, it is. So once that happens, I have to tell you that this tin is going to become a +2 ion. I have to tell you what it's going to become, or you won't be able to make your compound. So I end up with tin chloride. And now hydrogen's been kicked out, so it's diatomic, so it would be H2. No, you could put hydrogen and tin chloride. That's fine. So we would have to do a little balancing on this because I have 2 hydrogen and 2 chlorides. So I simply would put my 2 in front of the hydrochloric acid. The tin replace the hydrogen. Because if you look down a little bit farther, I don't have mine pulled up, but see where hydrogen is under the metals. So it's the exception, even though it's not a metal, it acts as a metal. So it's always going to be replaced by a metal in these types of reactions. Yes, because this became a +2 ion. So chloride's a -1. So I had to give it a subscript of 2 to make my correct ionic compound. So if we did this reaction, and this will be something we'll be doing similar tomorrow, the hydrochloric acid would be a liquid, and I'd put a piece of tin in there. And if this reacted, which it would, I would end up producing hydrogen. So what sign of a chemical reaction would I see with that? What is hydrogen? It is diatomic. It's also a gas. And when a gas is produced in a liquid, what do you usually see that tells you there's a gas in it? Some bubbles, right? So if we did this one, we should see some bubbles. So that's one of the things you'll be looking for tomorrow when you're doing your little different reactions. All right, we'll look at one more of these. This HOH is just the same thing as H2O. It's just written that way to show you that that nickel is just going to replace one hydrogen, not both. So is nickel strong enough to replace hydrogen? Is it higher on your activity series? So whenever it combines, it's going to become a +2 ion. So once again, it's kicking out hydrogen. So I'm going to have diatomic hydrogen. And then I'm going to form nickel hydroxide. And then this one would need some balancing, but it's easy to balance. I just have to put a 2 in front of my water. Yes, sir. No, it could be nickel hydroxide and then hydrogen, or switch it around. So just like I told you on Friday, they'll either be balanced or they'll be easy to balance on the quiz. Same thing on these. These should not, when you start on your practice and start looking at it, they should either be balanced when you write it correctly or be very easily balanced. All right, our next set now, instead of the metals, we're looking at our non-metals. So you're going to produce a lot of diatomics in this. So as I've graded these quizzes, people are still missing that quite a bit. So my chlorine is my non-metal. So in this case, it's trying to replace bromine. Chlorine is trying to kick out bromine. And if I look here, chlorine is 1 above bromine. So that means it is more reactive. It's strong enough. So I'm going to kick bromine out, which is a diatomic. And now I'll form sodium chloride. And then we would have to do a little balancing because I have 2 bromine. So I would put 2 here and a 2 in front of my sodium chloride, and that would get me balanced. All right, why don't y'all try that one right there where iodine is combining with potassium bromide. See what you get. Remember, before you do all your work, check your activity series, because if not, you're going to be upset you did a bunch of work and maybe you didn't need to. So did I need to do any work on this one? Because it's a no reaction, right? Iodine's down here. Oh, that's really going to help any. Iodine's down here is trying to replace the bromine. It can't. It's below it. So this is an NR, and I am through with that one. All right, from here, we're going to move to your lab. And I gave that to you early because you got to do a little bit of pre-lab on that. And we're going to go over that now. So tomorrow we're carrying out a bunch of single replacement reactions. So there's 2 of these on here, if you'll go to the second one that says prediction sheet with a very crooked pre-lab next to it. So this picture is representing what are called well plates, not like a well, like WEL, because they indent. So we're carrying out little reactions in each of those to see if they're actually going to be good reactions or if they're going to be NR. So you'll be looking for signs of chemical reaction like bubbles or like maybe a precipitin is formed or it changes color, those types of things, okay? So these are all going to be single replacement reactions. So before tomorrow, when you actually carry them out, you're going to predict today whether you think it's going to be a good reaction or not. So these, if you'll notice, all of these have S. So these are all metals. Like you're going to have a little piece of zinc, a little piece of lead, a little piece of magnesium. Actually, a bunch of little pieces. And down here, these are all my solutions. So I'm going to make an aqueous solution of all of those salts, all of those ionic compounds. The ones that are completely blacked out, those are where nothing will be. Those will be blank when you do it tomorrow. Because if you look at something like this, that zinc, if I had looked at that well plate, I would be putting a piece of zinc with some zinc nitrate. Well, zinc's not going to replace zinc. So there's no need of carrying that out. So those are why that one is black. All of those are black. Those will stay empty. All right, so let's look at another one that will not stay empty. So let's look at this one. And I'm going to draw an equation. You don't have to. You can if you want to. So if I look at this well, I'm going to put a piece of zinc. That's going to be one of my reactants. And then I'm going to put it, solution will be plus copper nitrate. Whoops. And on your prediction, all you're doing is saying whether it's going to be an NR or whether it's going to be an R. It's going to be a reaction. So we got to see, will zinc be able to replace that copper? Is that going to be a good reaction? Yes, it is. So you can just put R for reaction. That's all you got to put. Right now, you're just predicting. Tomorrow, we're going to see if they actually happen. So what I was saying is you probably don't have, you will eventually have to write some equations, but you probably don't for this. So for instance, if I look at this well right here, it's going to have lead trying to replace zinc because zinc's going to be put in all of those. So really all you need to do is know what your single metal is and what it's trying to replace. And from there, you can tell whether it's an R or an NR. So is lead strong enough to replace zinc? Is it? It's not, right? Because lead's down, it's below. So this one you would just write NR. So on this projection sheet, and on each of the little circles, it's either going to be an R or an NR. You're going to predict what you think should happen. And then tomorrow, we'll actually carry them out and you'll see if it matches up with what you predicted. So you got about 10 minutes so you can work on this and then you won't even have to worry about that when you get home. And then after that, you can work on your practice for a little bit. That's for the lab tomorrow. You're just doing the predictions today.
So we're trying to see if the solutions is metals or metals.
Well, it goes back to what we just learned. When we learned was the solution. Were we looking and seeing if the metal in the solution was stronger than the single metal, or what were we doing? Go back in your notes where we see, right. So you need to see if the single metal is strong enough to replace the metal in the solution. So just opposite. Yes, the practice is just single. Yes, just single replacement. Get it done, Mildred?